In this video we're going to continue looking at the binomial model, and we're going to do a few examples, and we're going to look at our calculator functions that will help us compute these probabilities more quickly. So our example here is that Mars Inc. Claims that 30% of each bag of M&Ms are blue. In a bag of 20 candies, what's the probability exactly 8 are blue? So again, notice that a bag of 20 candies, that means that we're doing a fixed number of trials. So number of trials equals 20, again as distinguished from the geometric where we're just waiting to get we would be waiting to get a blue one. Here we're just we're looking at 20 candies and we want to know the probability that exactly 8 are blue. So to use some notation, I'm going to say let x equal number of blue M&Ms. It's a bad and symbol, but number of blue M&Ms. We're looking for the probability that x equals 8. Okay, now so according to the probability, the binomial model, you've got your 20 trials. We're looking for exactly 8 successes, and the probability of each success is going to be 0.3, and the probability of a failure would be 1 minus 0.3, which would be 0.7. So success is a blue M&M, and failure is a non-blue M&M. So we want 8 blue M&Ms, so that's 0.3 times 0.3 times 0.3, 8 times, 0.3 to the 8. We want the rest to not be blue M&Ms, so that's 0.7 to the 12th. And again, it's tempting to stop here, but remember, you have to account for all the ways in which you can have blue M&Ms in the 20 slots. We should think of them as like slots. 8 blue M&Ms in the 20 slots. There's 20, choose 8 ways to do that. Okay, so this time I'm actually going to compute this out directly, and then in the next slide I'll show you how to use the distribution button. So to do 20, choose 8, go to Math, go over to the PRB button, and go down to NCR. Actually, sorry, before you do that, put 20, then you got to do that. So hit 20, then go to Math, PRB, and then go down to NCR. So you'll get, so on the screen it should be 20, NCR, and then you're going to put an 8. And so you can press enter here if you'd like. So that's a big number. And then we're going to times that by 0.3, 0.3 to the 8, and times that by 0.7 raised to the 12th. And you end up getting 0.1144. Alright, so there's a way to do that on your calculator. I'm going to show you in the next slide a quicker way to do that. Alright, so another problem, we want to again focus on the modeling in addition to the computing part of this problem. What's the probability in a bag of 20 candies exactly 5 or 6 are blue? So that word or should really suggest that you're going to be adding up two different outcomes, the probabilities of two different outcomes. So the probability there's exactly 6, or exactly 5 rather, would be probability that x equals 5. The probability that there are exactly 6 would be p that x equals 6, and we're going to want to add these. We're going to want to add those. So exactly 5 blue would be 5 successes, so that would be 0.3 to the 5th, and that would be 0.7 to the, so 5 are blue, that means the rest are not blue, which means 0.7 to the 15th. And then there's 20, choose 5 ways that can happen. Plus, this time we want there to be 6 successes, so 0.3 to the 6. And then the rest are failures, 0.7 to the 14. And there's 20, choose 6 ways to have 6 successes out of the 20. So this time I don't want to actually put in the calculator this because it's just a little bit, there's too many buttons to press. What you can do is go to second VARS, which will get you to the distribution button. And then go down to the one that says Binomial PDF. So you'll see the selection Binomial PDF. And this takes three parameters. It takes the number of trials, it takes the probability of success on each trial, and then lastly it takes the number of successes you're interested in. Okay. So in our example up here, we're going to want to punch in Binomial PDF, and the number of trials is 20. The probability of a success is 0.3, and we're looking for, in this case, 5 successes. And then I'll add that to this probability, which would be 20 trials again. Again, the probability of success is still 0.3, but the number of successes we're interested in is 6. And so if we actually compute that out, we get, drum roll, we get, I'm going to do it all out in one line actually. And I got 0.3705. So that'll end up being 0.3705. Great. So again, these are some. When you do these problems, you want to focus on the modeling aspect, which is essentially what I've done here. I mean, this is the modeling aspect here. And even here, if you're just, I mean, mathematically, this is what we're computing, that second line. But then what we actually want to do to compute it, just so it's not too much button pressing on our calculator, would be to use those functions that are built in to get an actual numeric answer. So in the next video, so these were individual events. In the next video, we'll do a few more examples that involve summing up multiple outcomes.